Hello everyone, my name is Sowmyalatha. My seminar topic is Test for Significance of a Small Sample. Testing difference between means of two sample on for dependent or paired observation. First see introduction. If the sample size is less than 30, that is n less than 30, the sample may be regarded as small sample and it is popularly known as t-test. In application of t-test, third application is testing difference between means of two sample on dependent or paired observation. The t-test produces two values as its output, that is t-value and degrees of freedom. The t-value is a ratio of the difference between the mean of the two sample sets and the variation that exists within the sample sets. In application of t-test, third application is testing difference between means of two sample on for dependent or paired observation. For example, if we take blood pressure data of a patient in the morning and again in the evening of same patient, together will become a paired data. Next see to test significance of difference between mean of two sample for dependent sample or paired sample. Like how big is the sale of a company before and after advertisement. Here we take such 30 sample and we have formula like T is equal to D bar divided by S divided by root n or D bar divided by S. And to find increment or difference between two sample, we have D is equal to x1 minus x2, where x1 is a sample 1 and x2 is a sample 2. And here D bar is equal to mean of increment, and in the formula S is sample. O is square root of summation of D minus D bar whole square divided by n minus 1. And degree of freedom nu is equal to n minus 1. And the size of each sample is the same, that is n1 is equal to n2 is equal to n. If there is no difference in the sample data before and after the advertisement, then mu x1 is equal to mu x2. If there is any difference in the sample data sale before and after the advertisement, then mu x1 is not equal to mu x2. If the sale is more before the advertisement and less after the advertisement, then mu x1 more than mu x2. If the sale is less before the advertisement and less after the advertisement, this type of equation is called two-tailed. This type of first H1 that mu is x1 is not equal to mu x2, that type of equation is called as two-tailed. Mu x1 more than mu x2, that type of equation is called as one-tailed, and mu x1 less than mu x2, that type of equation is called as one-tailed. Let's solve one problem related to this topic. First question, an IQ test was administered to 5% before and after they were trained. The results are given below. Candidates are 5 candidates is there. In first candidate, IQ before training is 110 and IQ after training is 120. Second candidate's IQ before training 120, IQ after training 118, and third candidate IQ before training is 120, the IQ after training is 125, and fourth candidate's IQ before training 132, IQ after training 136, and fifth candidate IQ before training 125 and IQ after training is 121. Test whether there is any change in IQ after the training program. Next, solve the problem. H0, there is no significance difference in IQ before and after training program. Here H0 mu x1 is equal to mu x2, h1 mu x1 is not is equal to mu x2. That type of equation is called as two-tailed equation. So now let's see, given sample data follows any of the following equation. So first we have to do one table. In this IQ before training, and we have to IQ before training in first column, and second column IQ after training. IQ before training is x1, IQ after training is x2, and then we have to calculate D. For calculating D, formula is x1 minus x2. x1 is IQ before training, x2 is IQ after training. So x1 minus x2, here in first candidate x1 is 110 and x2 is 120. So 110 minus 120 is equal to minus 10. 120 minus 118 is equal to 2. 123 minus 125 is equal to minus 2. 132 minus 136 is equal to minus 4. 125 minus 121 is equal to 4. So the total of this D is 10. So minus 10, sigma D is equal, summation D is equal to minus 10. Next we have to calculate D bar. The formula of calculating D bar is sigma D divided by N. So sigma D here we already calculated sigma D, that is minus 10. So minus 10 divided by N. N is the number of candidates. So number of candidate is 5. So 5 is equal to, answer is minus 2. Next we have to calculate D minus D bar. D means we already calculated D, and minus D bar is here we already calculated, that is minus 2. Minus is became a plus, so D plus 2. D bar is plus 2, so D plus 2. Here D is minus 10, first candidate D is minus 10, so minus 10 plus 2 is equal to minus 18, minus 8, 2 plus 2 is 4, minus 2 plus 2 is equal to 0, minus 4 plus 2 is equal to minus 2, and plus 4 and plus 2 is equal to 6. Next we have to calculate D minus D bar whole square. D minus D bar we already calculated in this before. We have to do square of 8 into 8 is 64, 4 into 4 16, 0 into 0 0, minus 2 into minus 2 is equal to 4, and 6 into 6 is equal to 36. So summation of D minus D bar whole square is equal to 120. The total of D minus D bar whole square. Next we have to calculate sample difference. Sample difference is D. S sample difference of formula of sample difference S is equal to square root of summation of D minus D bar whole square divided by N minus 1 is equal to square root of the summation d minus d bar whole square we already calculated. So that is 120, and n is number of candidate, that is 5 minus 1. So answer is 5.47. Next we have to calculate test statistic. For calculating this test statistic, formula is t is equal to d bar divided by s into n root n. Here d bar is minus 2, we already calculated, so d bar. So s is sample difference. Sample difference also we already calculated, that is 5.47 into root 5. N is number of candidate, n is 5. So next t is equal to minus 2 root 5 is 2.23, minus 2 into 2.23 divided by 5.47, it became minus 0.81. Answer is minus 0.81. Next we have to calculate degree of freedom is equal to nu is equal to n minus 1. N is number of candidates, that is 5, minus 1 is equal to 4. Next, tabulated t at 4 degree of freedom and 1% of level in level of significance, that is given in some data book. We have to doing that, seeing that we have to enter this tabulated t, that is tabulated t is equal to 4.0604. In calculated t minus 0.81, we already calculated that, and in tabulated data book that provide information, that is t is 4.604. So that is less than, calculated t is less than tabulated t. So H0 is accepted. This problem is H0 is accepted. Thank you.